Good morning. Good morning, students. सुनाई दे रहा है? आवाज आ रही है?
Good morning, ma'am.
Good morning. Okay. तो लास्ट क्लास में हम लोग डिस्कस किए थे फाइनाइट ऑटोमाटा के बारे में. इसमें 5 स्टेप्स था. ऑटोमाटा के जो definition है, it contains 5 tuples and the meaning of all 5 tuples we discussed on the last class. So according to syllabus, today we will discuss about the acceptance of strings. Okay, so this is a simple diagram of a finite automata. Why the name is finite automata? Because number of steps are finite. Okay, so here we have 3 steps. Okay, in this diagram, in this machine, basically we have 3 steps, and the arrow specifies the transition. Transition means from one state using one or more input, we can go to another state. So that is called transition. So how many states are there? 3 states, A, B, C. So in the definition of finite automata, the first tuple is finite set of states. That is denoted by capital A, which is written here. The finite set of states contains 3 states, A, B, and C. So double circle, the state having double circle is the final state, and any state.
Ma'am, your voice is not clear.
Hello, hello.
नहीं जो भी तो नहीं है कि
किसी को सुनाई नहीं दे रहा है?
नहीं
हेलो,
हम शुभम को
हेलो. अभी सुनाई दे रहा है?
Yes, ma'am.
Okay, okay. It depends on network speed. Well, हाँ, यहाँ पे जो 3 states and there is transition. So finite set of states contains state A, B, C. Okay. Symbol, how many inputs are there? Distinct input 0 and 1. So this alphabet contains alphabet denoted by sigma, that is 0 and 1. And the transitions function, that means all the transitions are written in this format. Delta denote the transitions. Okay. So in from state A, if you give input 1, it will go to state B. And suppose you are in state number A and you are giving 0, input 0, it is going to state number A or state A as well, it is going to state B. So I have written here A comma B. So using single input, it is going to more than one state. Okay. And when I am in the state number B, which is written here, delta of B comma in B comma 1 means the transitions from the state B using input 1. So the state is B and you are using input 1, and then it is going to where C, because in this arrow it is written 0 comma 1. That means using 0 it is also going to C, and using 1 it is also going to C. 0 comma 1 means this. The same thing is written here. Delta of B comma 1 equals to C, delta of B comma 0 equals to C. In this way, for C, we will get some transitions. So we are getting these transitions for C. Delta of C comma 1, that means if you give input 1 to state C, then it will go to the same state. So this is a loop basically, because it is going to the same state, the state itself, and using 0, it is going to itself the same state, and along with it is going to be. Okay, these are all the conditions. Okay, all the students, those who have joined, please write your roll number in the chat box. Okay. Then initial state that means who have the single arrow.
Ma'am, your voice is not clear, ma'am.
Okay, again I'm saying the initial state is where the single arrow is given. Okay. Single arrow is given. Final state is the last state where double circle is given to denote it is a final state, which is C. So A is equal to C. So hello. One thing I could do that if you say my voice is not clear, I could repeat. Okay, so whatever the portion you missed, please let me know. That's all I could do. Okay. Then we are talking about accepting of string. Okay, now in the last class we studied about the string. Strings are what? Strings are the combinations of input symbols. Okay, so there is no limitation. Any combination may be there that will be considered as string. Like here we have input symbol 0, 1. We have input symbol 0, 1. Okay, so two distinct input symbols. Because this 0, 0, 1 is a combination of this input symbol. And for string, there is a meaning of the sequence of the input symbol. Like 0, 0, 1 is not same as 0, 1, 0. Okay. But for this input symbol, the set in the set, you can write 0, 1 or you can write 1, 0 because you know the definition of set. It is a finite collection of elements. Okay. So this is a string 001 consists of this input symbol 001. Okay. Now we will check whether this string is accepted by this finite automata or not. Why the name is finite? Because the number of states are finite. And automaton because it is automatically works. It works automatically without human intervention. Just you have to provide the input and the transition will occur. Okay. Well, so at the beginning we are in initial state like state A, and if you put input 0, it will go to which state? B. From where we could know that whenever I am state in A, if I use input 0, so it is going to state number A as well as state number B. So as there are more than one transition using one input, any one you can choose for the transition you want to make. Okay, that is theoretically the machine will decide. There are some rules based on which the machine will decide. So later I will come to that. But for now, just think that you have input that is suppose first input is 0. So using that input, you are in state A and you are going to state B because there is a transition delta A comma 0 equals to A comma B. So you can go to A as well as go to B. So you are going to B. Now you are in state B and you are in state B and you are giving the next input symbol because the first one is processed. Then the second input came. That is the second symbol of the string, that is 0. So you are in state B using 0, where you can move or the transition can be done. B comma 0 equals to C. You can see that B comma 0 equals to C. That means it is traversing from B state to state number C. Okay. Then the present state is C now. And up to 0 we have processed. Remaining input is 1. So we will use input 1 on state C and it is again going to state C because there is a transition function which says delta of C comma 1 equals to C. That is using input 1 when the present state is C, you are going to state number C. That's it. So this is the total transition using this input string. Now we have to choose, or now we have to decide whether our string is accepted or not. So after using all the string, if we reach to a final state, then it is a accepting state, then it is the string is accepted. But if using the input string, if we cannot reach to any of the final state, then the string will be called as it is not accepted. Okay, string is accepted because C is final state. Right? There are some more examples, so I have taken another example over here. Okay. So see this diagram, some strings are given here. I will check whether it will work, whether it will find this acceptance or not. Okay.
लड़का को फिर से बोले तो बोला ना 4 यार मैंने लगा नहीं बोला 4 नहीं हमारे पास
Mute yourself.
अरे
Who is
बोले
calling?
तो 2500 का 2500 में खोज रहा
Monday. If it is not required, then please, if you are saying something, then it's fine. You are asking any question. Otherwise, please mute yourself. Okay. So this is another example. I think it is visible. This is another example, and this is a diagram of a finite automaton. With a number of states are finite, right? And we have to check the acceptance of these strings. Okay. So I should write the number of states here. Okay, I should write the number of states here. So capital Q means the total number of a finite set of states, that is A, B, then C. Okay, we have 3 states. And how many input symbols are there? Input alphabets is denoted by sigma, that is 0, comma 1. Okay, 2 input symbols are there. And what are the transitions? The initial state Q naught equals to A, and final state is F equals to what? D, because D is final state, right? D is final state. So you can just write this symbol here. What are the transitions exist here? Delta of you are in initial state and you are giving input 1. It is going to delta using 1. It is going to state number C. Okay. Then I am using delta from state number A. It is going to state number. If I use another input symbol from state A, that is input symbol 0, it is going to another state, that is B. Okay. For that, delta of B, that means the present state is B, using input symbol 1, the transition will say that it is going to the number of A, C, D. Okay. We don't have any B state. Instead of B, we have D state, right? So this is not B, this is D. This is D. Just consider that this is D. Just consider this state is D. Okay, so when we are in state number D, I'm rewriting it. State number D using 1, it is going to state A, delta of D, comma 0, it is going to delta of D, comma 0, it is going to where from this state using 0, it is going to be okay. Delta of C, comma 1, just 1 minute. Delta of C, comma 1, when you are in state C, when you are in state C using 0, you are going to state number C, delta of C, comma 0, no. When you are in state C and you are giving input 1, it is going to state D, right? So this will be D. And whenever you are in state C and you are giving input 0, you are going to state number C. Now it's okay. Now we will check the acceptance of string. So from state A, because it is initial state, if I use 0, then it is going to which state? From state A. If you are using 0, it is going to state number D. So I should write state number D. Okay, it is going to state number D. State number D. So that means D is a final state. Our final state is D, as I have written here. So I can reach to final state. So this is accepted. I am writing A, C, E, D. This is accepted. Okay. And so first string is accepted. Second string, which consists of just 1. Let's check. A is the initial state. If I give input 1, it will go to where? State number C. State number C. State number C, that means this is non-final state. So not accepted. This is not accepted. Okay. Then another string we will take, that is 0, 0. So I'm taking input A. Sorry, not input, the initial state is A. Then my string is 0, 0, right? So I am giving 0 here. So from A, if you use input 0, it will go to state number D. So I'm writing D. Again, from D, so first from this 0, 0, 0 is processed. The second 0 we will consider for processing. So I am taking 0 here. Okay. D using 0, it is again going to D. D is our final state, right? D is our final state. So this is accepted. Okay. Next, take another arbitrary string. There are so many strings, you can take any one of this. So I am taking 1, 1, 1, 1, 1, 1, right? Or just I could take 0, 1, 0. Let's take 0, 1, 0. Let's take 0, 1, 0. Okay. Initial state. If I use input symbol 0, then it will go to state number D. Again, if I use 1, because our input string is 0, 1, 0. If I use 1, it will go to from D. If you use 1, it will go to A. It is also written here. Delta of D equals to A. Okay. So I'm going to state number A. Again, my string is what? The remaining symbol of my string is, if I consider 0, 1, 0, left over is 0. and it is into from A using 0 you are going to D. So this is also accepted. So you will see using the string and so the diagram you can decide whether the transition whether the string is accepted by the machine, by the automata or not. Now you can observe, I think you have observed one thing, that using only one symbol here, only one transition or one movement here. You cannot see more than one movement using symbol 1, using input 1 from state A. Okay. So for each individual symbol, there is only one move from one state to another. जैसे कि यहाँ पे स्टेट ए को ही आप कंसीडर कर लो, यहाँ पे जीरो यूज करके, जीरो सिंबल यूज करके कितना ट्रांजिशन है, ट्रांजिशन है जो कि ए टू डी जा रहा है.
Ma'am, someone is waiting.
Okay. No, I cannot see anyone. No students are there. Okay. So what I was saying, that using single input or using individual input, there is at most one transition from one state to another. Okay, there are not more than one transition. So you can see for that we do it is easier to take the decision because for only one option, then you will choose that. But in case of the last transition, you can see you suppose from state A using 0, there are two movements. One was going to A and another was going to state B. So there are two movements. But for here, for the next example, you can see this total transition functions says that using single input or using individual input, there are only one transition, one distinct transition. Okay. So यहाँ पे आप देख सकते हो every entries of the right hand side of every transition function is a single element. Here we have C, here we have A, here we have B. But for this example, we have more than one symbol. Okay, common. So, by seeing that, we can understand one thing, that these are different types of automata. They are finite, but the type is bit different. One has more than one movement using single input, and one has only one movement using single input. So that it is easier to decide that where to go. Okay, for the second example, it is easier to decide where to go. This is called deterministic finite automata. Deterministic because it is very easy to determine where to go. But if there are more than one option, yes.
Like when the number of states are more than 3, then one variable will be for input and another will be the final one. So among them, the leftover 2, what will be the sequence while checking the string, that whether it is acceptable or not? Like A, B, C, D is there, and among them one is initial and one is final. And the left one, BC, what will be the sequence while checking the acceptance? Like CB or BC?
Listen, you have to start from the initial state, right? Suppose this is your example. You have to start from the initial state. Then whatever the transition is available from that state, you have to avail that. Suppose you are taking input 1 or this string 101. The string length is more. Like I can write 1 0 1 0 1 0 1. Let's say. Okay, this is a lengthy string. Okay. So you are initially you are in state A. You are using input 1, then you are going to state number C. From state number C, what is the remaining portion? This portion. So which is the first one? 0. So using 0, you are going to in the same state C. So the sequence came A, then C, then also C, because you are traversing from A to C, then C to C. So the sequence is A, C, C. Then the next symbol is 1. Okay, so from C, using 1, you are going to D. So what is our sequence now? I am writing the sequence A, C, C, then D. So, okay. And how many symbols you have traversed till now? 1, 0, 1, 0. Okay. So from A to C, it is 1. Then using 0, you are going to C. Using 1, you are okay. Up to this, we have used. So remaining is after this we have used. So remaining is 0 and present state is D. Okay. So from state D using 0 you are going to where? State number D. So up to this we have proceed and we came to state number D. Then next symbol is 1 from state number D. So next symbol is 1. That means we are going to using 1. We are going from D to A. So I am going to A. Okay, so next symbol is what? 0. Next symbol is 0. So from A to Z, using 0, we are going to state number D. Well, yes, going to state number D. And what is the remaining string? Okay, so from state number D, we are using 1. From the first symbol of the remaining. So from D, if I again use 1, we are going to where? A. So I am writing A. Okay. Which is remaining? Which symbol is remaining? That is 1. So from A, using 1, we are going to state number C. Well, so this is the sequence of our state, or the sequence of the transition. Okay. Well, so as we reach to state number C, and it is not final state because it is not represented by double circle. So this string is not accepted. So if you use this string in this diagram or in this automaton, then it will not reach, finally it will not reach to state number D, and last state you are getting, that is C, which is non-final. That's why this string is not accepted. Is it clear?
Yes, ma'am.
Okay. So now let's take the okay. So this is we have 10 minutes left. We today we cannot reschedule the meeting for the second class. I will close after the completion of this 40 minutes. So don't write anything on the board on this sharing screen, right? Please don't do this. Okay. So well, अगर कोई अपना रोल नंबर नहीं लिखा है चैट बॉक्स में तो प्लीज लिख दो। तो यहाँ पे हम लोग चेक करेंगे कि ये मेरा इनपुट स्ट्रिंग का लेंथ है। ठीक है, लेंथ कितना है इनपुट स्ट्रिंग का चेक कर लेते हैं। 1 2 3 4 5 6 7 8 इनपुट स्ट्रिंग लेंथ इज 5 and how many transition or how many states we are traversing? Let's check 1 2 3 4 5 6 7 8 9. You can observe one thing, that using whatever the number, whatever the length of the string, the number of state transition is one more that. Okay, so we are traversing how many states over here? 9 states, because we have input symbols, or the length of the string is 8. Okay. So this is one important thing. Some sort of questions or MCQ type of questions may be asked. This kind of concept comes in examination as a question. Okay. This is a simple thing. It's just a matter of observation. This is all about acceptance of string. And so in the last class we talked about the alphabet string, the length of the string, and clean start, clean clear. We just discussed about the
Ma'am.
acceptance of the string. Yes.
Please explain kin star and kin plus and
Yes,
language
yes,
again.
Okay, I will. Maybe today's time will be over. I'm trying to reschedule or restart the meeting. If it is not over, we will just put it at the rejoin. Okay, clean start. What is it saying? Let's open the page. Yeah, let me reflect this one. Clean start. Okay. In the definition, it is saying the clean start, that is sigma. Sigma is the input alphabet symbol, you all know. Is unary operator. That means unary operator, you have a concept of unary operator and binary operator, ternary operator, all these things. So unary means it has only one operand as well as one operator. So the operator is clean start and operand are the input symbols. Okay, the operand is, I should say, operand is the input symbol. Okay, unary operator on the set of symbol or string. Sigma is the sigma that gives the infinite set of all possible strings of all possible lengths over sigma, including delta. So just you read about this definition once more, and I am writing something over here. Sigma equals to suppose I'm just writing 0. So that in the input symbol, in the set of input symbol, how many input are there? Only one input, 0 only. There's only one input. And if I want to find out clean star of this, then what will it contains? It is saying that any combination of the string, all possible string, along with the null, including this delta, that means sorry, including the lambda. Lambda means the null. Lambda is null, but that means it is not containing anything. So length of is 0. Length of empty string is 0, which is called lambda, which is considered as null. Lambda is also called null. It is also called epsilon. It is also called null. Epsilon. So null means null is lambda. Also, it is called epsilon. That means it is not containing anything, and length of the string is length. Denote length of an empty string as 0. So length of just a. If I write length of a equals to 1, if I want to find out length of a, it is 2. Length of a is 3. Okay, and so on. And length of any empty string is 0, which is called null, or it is also called this epsilon. Okay, so it is contains, clean star contains sigma. I should write sigma star, which denotes the clean flavor. It contains null, along with any combinations of the input symbol which consists the string. So any combination, the first comes 0, second comes 0, 0, third, what may be the string 0, 0, 0, and fourth may be 0 to the power 4. I'm just writing 0 to the power 4. To the power means the repetition, okay, not the multiplication. To the power something means in automata 0 to the power 4 means 4 zeros. 0 to the power 5 means 5 zeros. That means the sequence and not the multiplication. Okay. So 0 to the power 5, 0 to the power 6, up to infinite. Up to infinite. That is called clean star. Up to infinite. That is called clean star. Okay. Now, if my alphabet consists of A, comma B, A, comma B, then how many input symbols are there? Distinct 2. So clean star of this is, the set is like that. It will contain none, and any combination of these two. Any combination of these two, like A, B, then what may be the combination A, next combination may be AB with length 2. Next combination means maybe BA. Next combination may be BB. So using length 2, there may be only these 4 combinations, right? Using length 3, what may be the combination A, B, A, then B, A, B. So how many combination may be there of length 3? So if there are 3 positions, in first position either A or B may sit. So two possibilities are there. This possible 2 possibilities. In the second position, we can sit either A or B. So 2 possibilities are there. In the third position, either A or B can sit. So there is also 2 chances. So the total number of combination may be to form string of length 3. Total number of combinations may be 2 into 2 into 2 is 3. Sorry, 8. So how many strings can be generated of length 3 where the input symbols are A, comma B? Each combination we offer. This is a simple mathematics.